So today you are learning how to draw box and whisker plots. Last week you learned about the different parts of the box and whisker plot. Today we'll review that to start, and then we'll talk about how to draw them. So remember, so sometimes they're called box plots, and sometimes they're called box and whisker plots instead. Either name is talking about the same thing there. And these just remember tell you how spread out your data is. And then this is always going to be split into 4 equal parts. And then remember, each section of your box and whisker plot, since you're splitting your data into 4 equal parts, each section will represent 25% of your data, which means from the whisker here to the start of the box, so this will represent 25% of your data here then. And then from the start of your box to your median, the line in the middle, so that'll represent 25% of your data. And then from the line in the center of the box to the end of the box, so that'll represent 25% also. And then from the end of the box to the end of your whisker here, it'll also be 25%. And then you learned about the important parts of the box plot last week, but we'll just review those. So remember this endpoint here, this is called your lower extreme. That's the smallest value that you're going to have in your data set. And these are always being plotted on a number line. So for this one, you can look straight down and your lower extreme will be 16 here then. And then the next important part in your box plot, this will be where the box starts, which will be this line here. So this is called your lower quartile then. And that'll be your median for the lower half of your data. And so here, if you look at your number line, so this is at 18 here for your lower quartile then. And then remember the line on the inside of the box, that's your median. So this will be at 22 for the median here then. So this is your median, which is the number in the middle when you put them in order from least to greatest. And then the next important part is the end of the box here, which is at 26. So here, 26, will be called your upper quartile. And that's your median for the upper half of your data. And then the last important part in your box plot here would be where this stops. So that'll be at 28. So that's your upper extreme, which is the highest value that you would have in your data. So for this one's your upper extreme, you can look at your number lines, your upper extreme for this one be at 28. And then, so for the chart here, so the first thing we're going to fill in, so this will be your lower extreme. And then like you learned about last week, so this will be the smallest number in your data set. And sometimes this will be called your minimum. And then the next important part of your box plot is the other side. So that's your lower extreme, be your upper extreme. And this will be the largest number in the data set. And sometimes it'll be called your maximum. And then next is your median. So remember, this is the middle number when you list them from your numbers from least to greatest. And then this is the line in the inside of the box. And then the next one, so this is your lower quartile. So this is the median of the lower half of your data set. And then the last thing will be your upper quartile. And this will be your median of the upper half of your data set. Okay, so we're going to look at the next set of questions here. So for this one here, this tells you to use the box plot below summarizing bowling scores for 19 students to answer both of these questions here. And so this is asking you which score represents your median. So you have the 5 key points here. So remember, your median will be the line on the inside of the box here. So since your box is here, your median is the line that's inside the box. So here's the line's at 143. So 143 will be the median then. And then for the next question here, this is asking what percent of the students bowl between an 81 and a 162. So this starts at 81 here and then goes up all the way to the 162 there then. So it has the 81 and goes to the 162 and stops here. So remember, each section of your box plot represents 25% of your data. So this whisker, the first whisker here, will represent 25%. So from here to where B is, that'd be 25% there. And then you have from 105 up to 143, which will also be 25% of your data. And then you also have another 25 here. So pretty much you'll have the 3 sets at 25%. So it's for that section, this section, and then from C to D there. So you have the 3 sections, it's 25% here, so that would be 75% then for this one. And then for the next question here, so you have 2 box plots that are graphed together. So we're comparing them. So this asks you which set of data contains the least value. So If you look at A, your least value, the lower extreme for A is at 25, and then if you look at B, it's 20. So the box plot that has the least value would be B, because your smallest value for B is 20, and then for A is 25. So this would be B then. And then for the next question, it asks you which set of data contains the greatest value. So you can look at your upper extreme. So for A, your upper extreme, you can look down at the number line. So this is at 65 for A, and then it's 70 for B. So B will have the greatest value because 70 would be greater than a 65. And then for 22, this asks you which set of data has the greatest interquartile range. Remember, to find the interquartile range, that's your upper quartile minus the lower quartile. So I'll write down the work for these here. So for A, for your interquartile range for A, so you can take your upper quartile for A, which is at 60, and then subtract your lower quartile, which is where the box starts, so which is 30. So you can do 60 minus 30 for that one. So that would be 30 then. And then you can do the same thing for B. So you can take your upper quartile for B, which is at 60, it's where the box ends, and then subtract your lower quartile, which is 40. That's where the box starts. So that'd be 20 then. So the greatest interquartile range would be A then, because 30 would be greater than 20. And then for 23, it asks you which set of data has the greatest range. So that's your upper extreme minus your lower extreme. It's pretty much asking you how spread out your whole data set is. So for A, this goes from, you're using this point and then your other point here. So for A, so you can do 65 minus the 25 there, which means if you subtract those, A will have a range of 40 then. And then for B, you can do 70 minus 20, which would be 50 instead. So B will have the greatest range because 50 would be greater than the 40. Okay, so for these here, so we're gonna draw a box and whisker plot together in the back here. So these are the steps you're gonna follow here. So your first step for these, so you're always going to plot the smallest value in your data set. So we have this data set here, so you can look in the chart here and figure out the smallest value here, which is going to be 45 for the strawberries. So this will be your lower extreme first. So like I said, to your lower extreme, so this will be at 45. So you can put your point halfway between the 40 and the 50 there. And then the next thing you'll do is to plot your largest value in your data set, which will be your upper extreme then. So if you look in at your data set in the table here, it's your largest value. So your upper extreme for this one will be 113 for the grapes. So you can plot your point at 113 then. And then, like it says, the next thing you'll do is you'll order your numbers from least to greatest. So our smallest number in our table up here would be 45. So you can write your 45 first then. And then your next number would be 69 then. And then your next number would be 73. And then after the 73, you'll have 81. And then after the 81, so you have 84 and 84, you have two 84. So you can list both of them here then. And then after the 84s, so you'll have 90 and then 113 would be your last one. Okay, so once you list your numbers from least to greatest here, then you're finding your median of your data set, which remember, the median is your middle number when you put them in order from least to greatest. So you can find this here. So you can cross off the largest and smallest values here and then work your way to the middle. So you can cross off these two to start, and then your next pair, and then, so you have these two numbers, the 81, the 84 that are both in here together. So you want to find the average of these two numbers because you're figuring out what's halfway between the 81 and 84. So for this one here, so you're going to add those together and then you can divide by 2 to figure out what your median would be. So if you do that here, you'll get 82.5 for the median then. I'm going to put it here. So this will be 82.5 for your median. So your median of the data set is 82.5 then. And then the next thing you're doing is plotting the 82.5 on your number line here. And then the next thing you're doing is step 5, then you're splitting your data in half. And then, so once you split your data in half, so pretty much where our line was to find the median here, right in the middle, this is your lower half of data, these 4 numbers below it, your median, and these are the upper half of your data from 84 up to the 113. The next set here, you'll find the median of the lower half of your data, which will be your lower quartile. So I'm going to use another color here. Okay, so I'm going to use blue. So you'll find the median for the lower half of your data. So you'll cross off these numbers here. So you'll cross off the 45 next here and the 81, and then you'll have both of these two numbers that are in the middle here, the 69 and 73. So you'll have 2 in the middle like we did with the median here. So your lower quartile would be between these two numbers here because it's split evenly. You have 2 below and 2 above here. So you'll want to average the 69 and the 73 kind of like we did with these two here. So you can add those together and then divide by 2 again to get the lower quartile then. So if you do that here, then you'll get 71 for your lower quartile. And then you can graph this on your number line, the 71. I'm regraphing this here. Okay, so your 71 would be like right around there. Or maybe a little to the right. And then you'll want to do the same thing to find your upper quartile, which will be the median of the upper half of your data. So I'll use the green here. So you're going to find your median of the upper half of your data to get your upper quartile. So you have these 4 values that are greater than your median, so you'll do the same thing here. So you can cross off the 84 and the 113 at the same time then, and then you have both these two, the 84 and the 90 in the middle, so they don't be kind of like the others here. So you want to average the 84 and the 90 to figure out what your upper quartile would be. So you can add the 84 and the 90 together, and then you can divide by 2 to get it. So if you do for this one, you'll get 87 for your upper quartile then, and then you can graph it on the number line. And then, so now that you have all your points there, so like it says next, they shouldn't say lower, but the next thing you should do, so you're boxing up your lower quartile median, your upper quartile median, and then your regular median, and then you can draw the whiskers to each side, to the lower and upper extreme. So your box will be in the middle here. It'll look kind of like this here then. So your box is in the middle there. So your lower quartile, that's your median for the lower half of data, your median, and then your upper quartile there. And then you're drawing the whiskers to each side for the upper and lower extreme, which are the largest and smallest values there. So that's what it would look like there. And then for these last 2 questions here, so this is asking you for the range of your data set. So remember, that's your upper extreme minus the lower extreme. So we figured out that your lower extreme is your smallest value, and then your upper extreme is the largest. So when we list them from least to greatest, so your largest was the 113, and then your lower extreme was the 45 there. So you can subtract. So you can do 113 minus 45 to get it. So if you subtract those there, then you'll get a range of 68 then. And then for your interquartile range, just remember, this is also the length of the box. It's also your upper quartile. I'm going to abbreviate this here, minus the lower quartile. So we figured out that our upper quartile was the 87 here. It was the average of it was the median of the upper half of your data. And then your lower quartile was the median for the lower half, which was 71. So you can do 87 minus 71 then to get it there. So then this will be 16 for this. So that'd be your interquartile range. And then, like I said, it's also the length of the box up there. It's kind of hard to tell what these values are at here, but you can also look up there since our upper quartile is at 87 and then your lower quartile is at 71. So that's also the length the box has 16. So you're going to work through the activities. So there's some matching things, and then where you're creating box plots. It's more practice like this, but let me know if you need help though.